On my screen, we have the drill project 4 assignment. This will be the project that you turn into me. As of right now, we've got the model complete. If I go back to the project page, we've worked our way through the modeling of the drill project 4, and we stopped at step 12 or step 11. And we were saving pretty much the entire way that we worked our way through the part. So we have completed this portion of the project, the modeling part. We're now going to move on to the creating of the toolpaths. So the first thing I'll need to do, step 1, make the toolpath manager or toolpaths manager visible and import a machine definition. I'm back inside of Mastercam. I've got the toolpath manager already visible. If you don't have it visible, what you'll need to do is go to view, and in the manager section, select toolpaths. The toolpath manager is visible. You can currently see that, you can see that there's nothing in the toolpath manager as of now. So what I'll do is I'll bring in a machine definition. I'll go to machine. In the machine type section under mill, I'm going to use the default. It takes a moment. In my case, it's going to bring in a machine definition. Not seeing anything, so I'll try it again. So machine, or it's still thinking about it. There it goes. So I brought in a machine group. I need to make some changes to the machine group. So if I expand it, so underneath the machine group inside of the toolpath manager, you'll find properties. If you expand it, you'll then see the files, tool settings, and stock setup. Before I do anything with the machine group, before I modify the settings, I'm going to go up to the file drop-down menu or the file tab. That brings me to this page. And then I'll select project manager. For the project file folder, this is where the Mastercam file is currently saved to. I would also like the NC files and the NCI files saved to this location. Now, once again, you guys can't create these files yet. I just want you in the habit of checking these settings. So when the time comes, you will be creating NC files and NCI files, and they'll be saved to the correct location. So from here, I'll select OK. To get back to Mastercam, I'll select the back arrow. And now inside of the toolpath manager, I'll select files. Opens up this dialog box. So for the group name, I'm going to change this to Haas VF2. And then I'll select the edit icon. That takes us to this page. We need to set the machine's maximum spindle speed to 10,000. That's what our machine's capable of. So in this section where it says mill spindle group, select the plus sign, expand it until you see tool spindle. So keep selecting the plus sign until you see tool spindle. Once you see tool spindle, double click on it. That brings us to this page. Now, when you bring in the default machine definition, the maximum spindle speed is set to 50,000. Change this value to 10,000. And once you do that, select OK. That'll complete all of the changes for this page. Select OK again. And that brings us back to this page. And that'll complete all of the changes that we make to the files page. From here, select tool settings. The default program number. This will be a 4-digit number of your choice. I'm going to call this 7504. If you're programming for a Haas machine, I do recommend that you avoid using 9000 series program numbers. From here, set the feed calculation to from material. In the toolpath configuration section, check assign tool number sequentially, check warn of duplicate tool numbers, and check use tools step peck and coolant. Once you do that, go down to sequence number. set the start value to 1, and then set the increment to 1. From here, go to the material section. We're going to start by selecting aluminum inch 6061. So go to the select icon, left click, brings up the material list. Now we only have one material to choose from at this time. So what I'd like to do is right click in this field. From the flyout menu, select get from library. And then select aluminum inch 6061. Once you select it, select OK. While it's selected, you can select OK again. And then that becomes the active material. Once you set the material to aluminum inch 6061, select edit. We're going to make a change to the material name. I'm going to remove or delete the inch. And then after the 6061, I'm going to type in dash T6. From there, go to base cutting speed. Set the base cutting speed to 300. And that'll complete all the changes that we need to make to the material definition. Select the green check. And that will complete all of the changes for this page.
Don't we need to drill base speed to 50?
That is correct. Thank you for catching that. So go back, edit. I missed that. So where it says percentage of base, set this to 50%. How I change this, I'll left click on it one time. I'll hit enter, and then I'll type in 50 and I'll hit enter again. So select it, hit enter, type in the correct value, 50, and then hit enter again. Now from here, we can select OK. And that'll complete all the changes that we need to make to this page. From here, go to stock setup. Stock plane should be set to top. For the shape, I have a solid model that accurately represents what the material is going to be. So I want to use that solid model. I'm going to go to solid mesh. And then if I select this icon, that allows me to go back into the graphics area and pick select the solid model that represents our material. Now I currently don't have that visible on my screen. So I need to make the level manager visible. So I'll go to view, levels. I'll make the material level visible. And now I need to carefully select the material. And I'm going to select inside of this circle. And once I do that, you can see that the dimensions match the material dimensions. So 3 by 2 by 1. I can select display. That'll give me a preview of what the size of the material is going to be and where it's going to be located. So I've got display checked and I've got solid selected. Now you have 2020 or 2022. So this is going to, I believe it says shaded instead of solid. So check shaded. And then from here, select OK. I'll make the material level invisible. If I make the solid model level invisible, this red rectangular shape, that represents our material when we go inside of verify. So from here, I'll go back to the toolpath manager. I can toggle the display of the stock off. Click on this icon right here. I'll make the solid model level visible. And then I'll go back to the toolpath manager. One last thing we'll do prior to bringing in or prior to creating stock models and toolpaths, we're going to change this toolpath group -1 name. This is a generic name that Mastercam comes up with or Mastercam provides. I'm going to change this to first operation. To do that, select it and then right click on it. And from the flyout menu under groups, you'll find rename. And I'll call this first operation. You'll see the insertion arrow underneath the first operation toolpath group. And this will be a good time for me to save my work.
How did you add first operation again?
So it says the default name is toolpath group -1 or something like that. So all I did was I left clicked on it. Then well, there's a couple ways you can do it. I just right click on it, and from the file menu, I select groups, rename. Then I just call it first operation. That help?
Yeah, thank you.
Welcome. All right. So from here, I'll go back to the project page. And all of that was step 1, make the toolpaths manager visible and import machine definition. I'm sorry, that was step 2 also. Modify the settings in the machine definition to reference machine group properties found below. So when you're doing that, when you're setting up the machine definition, I've got a few images of the different tabs or different pages inside of the machine group properties. And the group name, we change that. We modify the maximum RPM. I come down here, you can see some changes that I make. And then here, this one says rectangular, but what we've been doing is we've been selecting the solid model. So I would select this icon and then pick select the solid model that represents our material. So that gets us back to step 3. It says use the drill toolpath to create pilots for all through holes on the part. We're going to use a spot drill to do that. But before we create the toolpath, we're going to create a stock model that represents the material prior to any machining. So I'll go back to Mastercam. I'll go to my level manager and I'll make the material level visible again. I'm going to use the solid model that represents the material to define the stock model for our toolpath manager. So inside the toolpath manager, you can see the insertion arrow is underneath first operation. I'm going to go to the toolpath tab, and in the stock section, I'll select stock model. The parameters page for the stock model appears. For the name, I'll call this raw stock. You want to name it something that makes sense, something that'll make sense down the road. We'll call this raw stock. Stock plane, I have it set at the top. For the initial stock shape, once again, I want to have Mastercam reference that solid model of the material. So I'll select model. Then I'll select this icon. That allows me back into the graphics area. I'm going to pick select the solid model that represents my material. And selection. I don't think it worked. Oh, I'm so yeah. So I wanted model. There we go. I had to triple click on it. I think. Let's see if it works. So I selected model. I selected the stock model or the solid model of the material. Select OK. It's thinking about it, and it worked. So I have 2 stock representations and then the solid model of the part overlaying each other. So it's a little bit difficult to see. I'll make the material level invisible. And then if I go back to the toolpath manager, I can toggle off the visibility of the stock model, same way I would toggle off the visibility of a toolpath. This icon right here, toggle display. And while it's visible, I'm going to inspect the part, make sure everything looks correct. And once I verify that it's correct, I'll just toggle off the visibility. Look at it from an isometric view, and I'll save my work. So how's everyone doing up to this point? Okay. I got the thumbs up. We're good. Lydia, you have a question?
Yeah, mine looks different.
Different. How so? May I see your screen?
Yeah.
Okay, 1 second. You should be able to share.
Did it work?
I'm not seeing it yet. Hold on.
Okay. It says you are sharing screen.
1 second. Try it now. There we go.
Okay.
Yours looks different. Reason being is I think you selected the solid model that represents your part. So make the material level visible.
Okay.
Okay, so see how the holes are filled in? Now
Oh,
go back to your toolpath manager. So bottom left of your screen,
oh,
yeah, right there, select that. Now go to the parameters of the stock model and select the cursor icon again. And this time I want you to pick inside of, there you go, select that one.
should I triple click?
Yeah, try triple clicking.
Hmm.
I think we're okay. I'll hit okay again. Maybe no, you have to regenerate it. So you see how there's a red X next to it? So select one of the regenerate icons, top of the toolpath manager, go up about, nope, top of the toolpath manager. So that thing that's in the
Oh,
left,
sorry.
no problem. Go over one or two icons and you should be good. Either one of those should work.
Regenerate. Okay.
There you go.
Oh,
See how
okay.
you see how I filled it in? So you just
Yeah.
got to be careful if you got the material solid visible and the part solid visible. Selecting the area where the holes drilled out for the part, and then you'll select just the solid for the material. All
Okay.
good?
Yeah, thank you.
You're welcome. I'm gonna go back to my screen. Okay. So I've got my material level. I have the stock model complete. I'll go back to the project page. And you guys can see my screen, correct?
Yes.
All right, perfect. So we're on step 3. Use the drill toolpath to create the pilots for all through holes on the part. If I scroll down to the very bottom of the project page, tool 1 is a 1/2-inch diameter spot drill, 90-degree DPA. We've used this tool for every project so far in this class. So tool is going to be C4C3-0032. The tool projection will be 1.5 inches. So make sure the insertion arrow is at the very bottom of your toolpath group. You're going to go to the toolpath tab. In the 2D section, select drill. Mine's running a little bit slow, so it brings up the toolpath hole definition dialog box. And this is where we select the geometry to drive our toolpath. Now, in this case, I can use a selection filter or I can pick select the circles that I want to represent the holes in my part. So in this case, I'm going to use the mask on arc icon right here. It's asking me to select an arc to match. I'm actually going to select the larger circle on the top of the part. I'll actually select this one right here. Once you select it, the prompt changes. It says use a window select, Control A, or the arc quick mask to find matching arcs. If I just come over here and select the upper left half of this icon, select all arc entities, all matching circles become selected. And then you'll see a point at the center of the holes. That's the location where the hole will be drilled. And you'll see some lines connecting them, showing us the order that the holes will be drilled in. And the first hole to be drilled is designated by the red center point. Now, if you need to change the order that they're being drilled, you can come over here where it says sort, expand this menu. And you have different options here. And in this case, let's say I wanted the first hole to be drilled, the hole that's closest to the origin. It's not necessary that you do it this way. I'm just giving you an option here. So I'll select this option right here. Now this would be the first hole to be drilled. It's going to step over along the x-axis. Then it's going to step up and then start stepping over in the x-axis again. So this looks good. From here, I'll select OK. And that allows me to access the parameters for the drilling toolpath.
Oh, sir, Professor, if for some reason my computer's not allowing me to select an arc to match.
Interesting. Can I see your screen? Can I see
Yeah.
your screen?
Select an arch.
So
Arc, I mean,
You'll select that one, yeah. Oh, so
Like this?
no, no, do you have your wireframe visible or is that just the solid?
Oh,
See,
whoops.
yeah, so what you could do,
I should have
no, you're good. That should work just fine. All right, so go back to the toolpath manager. Now this is 2020, so it's going to function a little bit differently. Now select arc to match, zoom in, and you got to be real careful. See, that's a surface. Go up, hover over it, and it should highlight an edge, and it should change its appearance. If it's going to be this way, let's do this. Go to your level manager. Make the solid model level invisible. Now select that one. Now scroll out. And I would just do Control A. See how that worked?
yeah, you see, you gotta.
Yeah, so that's one of the advantages of organizing your work by color and by levels. You see how you can turn levels off and you can make a thing, you know, it makes accessing other things a little bit easier. So
Got it.
that's how that works, or that's an advantage of organizing your work that way. All right, so I'm gonna go back to my screen. Yeah, so it looks like in 2022, the way Mastercam responds to hovering your cursor over certain items has changed a little bit, and I don't think I like it yet. So from here, I'll go to Tool. And you guys can see my screen, right?
Yeah.
Okay, perfect. So I'm looking at my tool list. The tool list is currently empty. I want to add a tool to the tool list. You can select the library tool icon, or you can right click in this field from the flyout menu, select library tool. And it brings up the tool library. Now my filter is active, so I can only see one tool. So what I'll do is I'll select the filter icon. I'll deselect any tool types that are currently selected, and then I'm going to select spot drill. And for the tool diameter, I'll set it to ignore. And then I'll select OK. It's showing me all the spot drills coming out of the library. I'll select the 1/2 inch diameter spot drill. Now you'll notice that this is tool number 24. When I double click on it, it should be added to my tool list as tool number 1. That is the assign tool number sequentially option that we have checked over in tool settings. So I'll double click on 24. It's added to my tool list as tool number 1. To make changes to the default settings, I'll right click on it and then I'll select edit tool. On this page, things that I will change where it says cutting length. I'm going to set the cutting length equal to the drill tip length. And in this particular case, it's 0.25. The yellow shaded area represents the cutting length. For the shoulder length, I'll set this to 1. Mastercam only allows us to hold on to the dark gray part of the tool. That's just a setting, or that's what it requires from us. So I'm reducing the shoulder length to 1. And that'll allow me to set my tool projection to 1.5. So from here, I'll select next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM based off of the cutting speed that we told it to use, select the calculator. So the SFM, that's our cutting speed, is 150. And that calculates, and our RPM calculates to 1,146. To turn on the coolant, you can select show more options. You can select coolant. Set the flood coolant to on. And then select OK. And that'll complete all of the changes that we need to make to this page. From here, select finish. The RPM has already been calculated. For the feed rate, we need to set the FPT. With drills, think of it as feet per revolution, FPR. Set this to 2% of the tool's diameter. The decimal equivalent is right here. So 0.5 times 0.02. That's calculating my feed rate at 11.46 inches per minute. Once you set the feed, go down to the comment section. For the tool name, actually, I'm going to borrow the tool name. I'll paste it in the comment section. And we'll say drill all. Now this is all capitals, drill all pilot holes. And that'll complete all of the changes for this page. From here, go to the holder. We're going to use a Cat 40 ER32 tool holder. That information is right here, C4C3-0032. So instead of looking through this long list of tool holders, I can isolate a particular library. So if I go to open, and we're looking for Cat 40 inch. So in the CT40-IN folder, select open. C4C3-0032, and then set the tool projection to 1.5. Once you do this, go down to cut parameters. I'm just checking to make sure that it's set to drill / counterbore and the dwell value set to 0. This will create a G81 drilling cycle inside of our NC file. Once you verify that this is correct, go down to linking parameters. Activate clearance, set it to 2 inches absolute. I'm going to check use clearance only at the start and the end of the operation. For the retract, I have it set to incremental 0.1. Top of the stock, I'll set this to absolute. Now I can see that the origin is sitting on the top of the stock, but there will be situations where that's not the case. And what you can do is you can select top of stock, and then you can pick select a piece of geometry that represents the top of the part. So I'll select this corner right here. The value is coming in at 0 absolute. For the depth, I'll set this to absolute. I'll select the depth calculator, and I want to create a pilot equal to the diameter of the countersink. Now we modeled up this part based off of the drawing. The model is accurate. So what I can do in this case, where it says finish diameter, I can click in this field, I can right click, and from the flyout menu, I can select diameter of an arc. That allows me back into the graphics area where I can pick select the circle that I want to match my countersink to. So if I select this circle, now, Brian, you see how mine's acting a little different than yours? When I position my cursor over a face, you see how that icon that pops up next to my cursor, it looks like a square? That's indicating that I'm hovering over a surface. And then as I get close to the edge, you see how it's changing to an E, so surface. So it's yours is acting a little bit more, it's not cooperating like I would like it to. So in this case, if I select the edge, but if it's not letting you do it, what you can do is go to level manager, make the solid model level invisible, and now you can select the circle here. And then it takes the diameter value and places it in this field. I'll check overwrite depth. So finish diameter is 0.45, select overwrite depth, then select OK. One last thing I'll check, make sure that tip comp is turned off. You see the circle, the red circle with the diagonal line going through it. That's telling me that it's turned off. So from here, I'll select OK. I'll make the solid model level visible again. I can see a preview of the toolpath. The yellow lines represent rapid moves. The blue lines represent feed moves. I'm not seeing any yellow lines moving through the solid model. Everything appears to be correct. So what I can do is I can select just that toolpath. I can select backplot. You can see the tool holder. I'll slow it down a little bit. I'll select play. Everything looks good. I don't see anything that could cause a problem. So I'll exit out of backplot. I can toggle off the visibility of the toolpath. I can select this icon here. I'll look at it from an isometric view. And I'll save my work. I like to save my work prior to going into verify. That'll be the next thing that we do with this project, or next thing we do with this toolpath. So to run it and verify, I usually just select the entire first operation, or I select the toolpath group, and that'll select everything within that toolpath group. Now, if a stock model is selected, it's not going to be a problem because we will not see the stock models inside of verify. So with everything selected, I'll select the verify icon. Takes a moment to open up. Once you're inside of verify, make sure the stop condition collision is turned on. I'll select play. And it ran a little quick. Once it's complete, what I'll do is I'll inspect the machined model to the wireframe representation of the part. And in this case, you can see that it's a little jagged. I have some limitations due to my graphics card or to the level of precision that I held it to. But for the most part, it matches up with the circle that represents the diameter of the countersink. So I'm happy with that. And I don't have any collisions. So looks good. So from here, I'll exit out of verify. Isometric, fit, unzoom. And I'll save my work. How's everyone doing?
I had questions, sir.
Yes, sir.
Yeah, because mine look like all the hole had been go through. I don't know if I forgot to turn off something.
Can I see your screen?
Yeah.
All right. So did you run it and verify, or?
Yeah, I run the verify.
Okay, so let's look at before you run. Let's see what it looks like in backplot. Run it in backplot. So select the toolpath. There it is. Now run it in backplot. Up, up. Backplot is the go up one more, and over one. Other side, other direction. Over right there. Yes, run that. Hit the play button. So that looks good to me. I don't see any issues, but let it finish. Okay, so that looks good. Close out of that. Now go to verify. That's the icon next to backplot. Yep. Oh, so when you created your stock representation, so exit out of there. Go to stock setup. Up, nope. Stock setup right there. Select the cursor icon. Now go to your level manager. Nope. Level manager, make your material level visible. Now select inside of the circle. Yeah, right there. Yep. Hit OK. And go back to your toolpath manager. Now I'll run it. I might have to turn the material off, but I think we'll be okay.
Got it.
So yeah, when you selected your material, your raw material, I think you accidentally selected your solid model solid model of the part. So that
Yeah.
looks good.
All right.
All right,
Thank
so
you,
we'll go-
sir.
You're welcome. We'll go back to my screen. So you guys can see my screen, right?
Yeah.
Got my initials on it.
Levels, can we see
Alright.
your level we're tracking?
Yes. All good?
Yeah, we have 11 for solid support geometry.
So it looks like you got one extra item. And that could be anything. What's on your solid model level?
Just one.
Okay, so I wouldn't worry too much about it. Or what you could do is, if you look at it, there's gonna be 4 lines and 6 circles. That's all there should be. When it's all said and done, if I make that level active, that's all there should be. That's all I needed to create the solid model of the part. And if you go to that level and you make just that level visible, and if you try to delete something, it's going to give you this. Watch what happens. Now, don't do this. I selected the circle. I hit delete. I'm getting this warning. It's saying, hey, this circle or this item that you're trying to delete is supporting something else. So if you ever see this warning, deleting a reference item, just hit the red X, cancel out of there. So I wouldn't worry too much about it. But just so you know that all I've got on that level is 6 circles, 4 lines. Does that help?
Yeah, I might have dropped an extra point somewhere, but I'm not seeing it. But okay, I won't worry about it. Just
Yeah, it's
curious.
not a big deal. You can go in there and clean it up. And like I said, if you delete something, you could try hitting the delete duplicates. You might have 2 pieces. You might have 2 lines sitting on top of each other. You might have 2 circles sitting on top of each other. So when you go to delete duplicates, it's not going to delete the item that has something dependent on it. And like I said, if you ever see that warning, just back out of that command, hit the red X. All right, so we've created and verified that the spot drilling operation will work for us. Let's create a stock model that reflects everything we've done up to this point, reflects the machine that we've done up to this point. Make sure that the insertion arrow is at the very end of your toolpath group. Go to the toolpaths tab. In the stock section, select stock model. And for the name, we'll say like drill pilot holes or something like that. Just something that makes sense. For the initial stock shape, we're going to use a stock model. Let's use a stock model that represents the raw material. So I'll select stock model. I've got raw stock selected. That's the only option I have at this point. And once you do that, go to the source operations and select the drilling operation that we just created. Then once you do that, select OK. Takes a moment to process. And we now have a stock model that shows the pilot holes drilled in it. And if you're having a hard time seeing it, you just go back to level manager and you can toggle off the visibility of the solid model. And that's what our part's going to look like sitting on the machine right after we drill the pilots. And once you verify that everything's correct, go back into the toolpath manager and just toggle off the visibility of it and save your work. How's everyone doing?
Good.
Perfect. All right. So from here, we need to create the next drilling operation. Let's go back to the project page. Let's see what we're instructed to do. Step 4, use the drill toolpath to create the holes in the part. If I look at the tool list, we're using a letter X drill. It's got a 0.397 diameter, 118-degree DPA, and we're instructed to use a C4C3-0032 tool holder. The tool will be sticking out of the collet 2 inches. So all that information is provided to us here. So from here, I'll go back to Mastercam. I'm going to add another drilling operation to this this drilling or this toolpath group. Insertion arrows at the very end. I'll go to the toolpath tab. In the 2D section, I'll select drill. It's asking me to select the holes that I want to drive this drilling operation. I could use the arc mask or mask on arc. I'll select this circle. And then I can window select the rest of the circles. And then once I do that, you see all the circles that match the diameter of the masked arc. You can see the order that they're going to be drilled in. And once you have all of them selected, correct, or once you have all the holes selected, hit OK. Brings up the parameters for the next drilling operation. I'll start by adding the letter X drill to my tool list. I'll select tool. I'll select library tool. I have the filter active, so I'll select the filter icon. I'll deselect all tool types, and then I'll select drills. For the tool diameter, I'll set it to equal. And if you know the decimal equivalent of a letter X drill, 0.397, you can type that in. Or if you know the letter size drill, you just type in £, the letter X, and hit enter. So we're looking for a drill that has a diameter of 0.397. If I select OK, I've got one tool that fits that description. It's tool 152. When I double click on it, it's added to my tool list as tool number 2. We'll need to make some changes to this tool. Right click on the tool. From the flyout menu, select Edit Tool. Change the shoulder length to 2. So that's the only change I'm making on this page. I changed the shoulder length to 2. From here, select Next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM, you can select the calculator. It's calculating the RPM at 1,443. It's based off of this almost 150 SFM cutting speed. There's a rounding thing going on there. For the coolant, select Show More Options. Select Coolant. And then set the flood coolant to on. From here, I'll select OK. And that'll complete all of the changes that we need to make for this tool. So from here, I'll select Finish. The RPM has been calculated, 1,443. We need to calculate the feed rate. Set the FPT equal to 2% of the tool diameter. So in the FPT field, I'll type in the decimal equivalent of the tool, 0.397. And then multiply it by 0.02. And it's calculating my feed rate at 11.4, so we'll call it 11.46. Mastercam will round this to 2 decimal places when it places the feed rate in our program. From here, we need to provide a comment. I'll borrow the tool name from the tool name section. Paste it in the comment field. And provide some type of information. Drill all holes through. And that'll complete all of the changes that we need to make on this page. From here, go to the holder. We're going to use the same tool holder as we did in the previous operation. So I'll select Open Library. We're going to go to CAT 40 inch, so CT 40 inch. C4C3-0032. Set the tool projection to 2. That completes all the all the changes that we need to make on this page. Go to cut parameters. Now, when we selected the letter X drill, this is what's referred to as a jobber drill or a regular style drill. Mastercam changes over to a PEC drill cycle, and the PEC increment, this will be the Q value inside of our drilling cycle. The PEC increment is equal to the drill tip length. So once you verify that this is correct, you're going to go to linking parameters. A nice thing about using similar toolpaths inside of Mastercam within the same session, it'll hold on to a lot of the settings. So in this case, this clearance at 2 inches, absolute, that works. I'll leave this checked. The retract at 0.1 incremental is correct. Top of stock is 0 absolute, that's correct. The depth, I've got it set to absolute. I'm going to select the depth icon. I'll let my cursor lock on to something that represents the bottom of the part. Once I see it lock on, left click. The Z value should be -1. That's relative to the origin or our coordinate system. This is telling Mastercam how deep to drill this hole. And if I drill to a depth of Z minus 1.0, the full diameter of the drill is not going to go all the way through. So what I need to do is I need to turn on tip comp. So select it, activate it, set the breakthrough amount to 0.025. And this will tell Mastercam the additional depth to drill to so that the full diameter of the hole, so the full diameter of the drill goes all the way through the part. And that'll complete all the changes that we need to make to this page. So from here, I'll select OK. We can see a preview of the toolpath. You can see that the drill goes all the way through. When it's repositioning itself, it's not traveling through the part. So I like what I see. To run it in backplot, I have just that new toolpath selected. I'll select the backplot icon. I'll speed this up a little bit, and then I'll select play. To guarantee that, to check that the drill is going all the way through the part, if I look at it from a front view and then zoom into the bottom, I'm hitting the S key. And you can see it's going to its final depth for this particular hole. Back it up, hit the S key again. You can see that the full diameter is coming through the bottom of the part. So that's what I'm checking for. And once I verify that that is correct, I'll select play and let it run out. I'm not seeing any type of issues with backplot. So from here, I'll exit backplot. I can toggle off the visibility of this toolpath. So with it selected, I'll select this icon here, toggle display. I'll look at it from an isometric view, fit my screen, unzoom 80%. And before we run verify, I recommend saving your work. When I run inside of verify, I want to make sure that I have everything selected. So I'll select the first operation toolpath group. You'll see green checks appear next to everything. Once you verify that everything is selected, select the verify icon. Inside of verify, always make sure that stop condition collision is turned on. And then select play. I'm tumbling the view. I'm inspecting the machined part. Just making sure that the drilled holes go all the way through the part. I've got a full diameter going all the way through. Looks good. So from here, I can exit verify. And I'll save my work. So now that we've created the drilling operation that goes all the way through the part, let's create the stock model that reflects everything we've done up to this point. So once again, insertion arrow is the last thing, or it's at the very end of our toolpath group. From the toolpaths tab, in the stock section, select stock model. For the name, I'll say drill holes through. For the initial stock shape, we're going to use the stock model from the previous operation. So stock model selected, I'll select the drop-down menu. I'll select the drill pilot hole stock model. From here, I'll go to the source operation page, and I'm going to select the toolpath that we just created. Once you do that, select OK. Now it's difficult to see because the stock model pretty much matches the solid model that represents the part. So what I'll do is I'll go to the level manager. I'll make the solid model level invisible. And this gray representation of the part, that's our stock model. And it appears to be correct. And once you verify that it's correct, I'll make the solid model level visible again. And then I'll toggle off the display for the stock model. From here, I'll go back to the project page. We're on step 5. Use the contour toolpath to create the engraved initials on the part. If I look at the tool list, tool number 3 is a 1/32 diameter ball mill, 0.03125 in diameter. 2 flute tool, there's going to be a C4C4-0016. This is a Cat 40 ER16 colleted tool holder. And then the tool is sticking out 1/2 of an inch from the collet. All right, so from here, I'll go back to Mastercam. This is a contour tool path. Now be careful. All the engraving that we do in this class, we're going to use a contour tool path. Do not use the engraving tool path. That's a different monster. And in this class, we're going to teach you guys how to engrave using the contour tool path. So select the contour tool path, 2D section, contour. That brings up the wireframe chaining dialog box. The initials that we created are built from wireframe geometry. We've got lines and arcs. So for the mode, I've got it set to wireframe. Select 3D. And then for the selection method, select window. Now, what I like to do when I'm doing this, I like to look at it from a top view. So right click on the screen, select top. And then I'll zoom in a little bit. I'm going to create a window that captures all the geometry that represent my initials. So if I left click here and drag, you can see the selection window that I'm creating. It's a little difficult to see. It's blue and then the solid model is blue. So I clicked somewhere off of the part and then I'm dragging it to basically create, capture all of the geometry that represents my initials. Left click. Now it doesn't look like anything has happened, but this prompt has changed. It says sketch approximate start point. I'm going to let my cursor lock onto the endpoint, the bottom left endpoint of my first initial. Left click. And once you do that, everything becomes selected. From here, I'll select OK. And that'll bring up the parameters for my contour toolpath. Now you might have a different number of chains driving this toolpath depending on your initials. From here, I'll select tool. We're going to add a 1/32 ball end mill to our tool list. Select library tool. Now my filter is still active. So what I would have to do usually is go to filter, deselect all tool types. We're looking for a ball mill. It's called end mill 2 sphere. So select this icon. And it's a pretty small tool. So instead of looking through every ball mill that's available and that's coming out of this library, I'm going to set it to less than, let's say 0.125. I'll select OK. And there are only 3 tools that fit that description. And you can see our 1/32 ball end mill is tool 301. It's in the list or it's available. Double click on this tool. It's added to our tool list as tool number 3. We're going to need to make some changes to the default settings for this tool. Right click on the tool. From the flyout menu, select edit tool. On this page, the only thing I'll change is the overall length. Set that to 1. Go to the next page, select next. For the number of flutes, set this to 2. That information is coming from the tool list. To calculate the RPM, I'll select the calculator. I can also turn on the coolant. I'll select show more options. I'll select coolant. Set the flood coolant to on. And then select OK. And that'll complete all of the changes that we need to make to this page. So I'll select finish. The RPM, it's maxed out at 10,000. For the FPT, let's set this to 1% of the tool diameter. This isn't a drill, it's an end mill, so we're going to use a different percentage. Set this to 1% of the tool diameter. The decimal equivalent is 0.03125. So in the FPT field, I'll type in 0.03125 times 0.01, hit enter. It's calculating my feed rate at 6.25. This is the feed rate that it's going to use when it's moving in the XY plane or along the XY axis. For the plunge rate, this is movement in Z. Let's set this to half the calculated feed rate. So what I'll do in this case, I'll start with 6.25 and then divide that by 2. So all of our moves along the XY planes or along the XY plane will be 6.25 inches per minute. Any movement in the Z that's considered a feed rate is going to be 3.125 inches. In the comment field, I'll copy the tool name, paste it, and then once again, provide some type of useful information. All caps, engrave initials. From here, I'll go to the holder. Now this is a Cat 40-inch tool holder, so I'll select Open Library. I'll select Cat 40-inch. And we're looking for a C4-0016. Set the tool projection to 0.5. And that'll complete all of the changes on this page. From here, go to cut parameters. For the compensation type, because we're engraving with this toolpath, we want the center line of the tool to follow the geometry that's driving it. Let's turn compensation type to off. Contour type should be 2D. For the stock to leave on wall, set this to 0. That completes everything on this page. Now we need to turn off depth cuts, lead in, lead out, and multi-passes. Multi-passes is already turned off, so select depth cuts. To turn it off, uncheck it. Then select lead in, out. To turn it off, uncheck it right here, the upper left corner, uncheck it. Breakthrough is turned off. Multi-passes already turned off, and we don't use tabs, so that's off too. So everything under cut parameters is turned off. For the linking parameters, set the clearance to 2 inches absolute. And I'll check use clearance only at the start and the end of the operation. For the retract, I'll set it to a couple different ways we can do this. We could have it set to absolute 0.1. Set the feed plane to 0.05 incremental. Top of the stock, I have it set to absolute. If I wanted to, or if I didn't know the Z value of the top of the stock, I could select top of stock. Tumbling my view. When I select top of stock, it lets me go back into the graphics area, and then I can let my cursor lock onto something that represents the top of the part. 0 absolute, that's correct. For the depth, in this particular case, I'm going to start by selecting the top of the part. So set it to absolute, select the depth icon. Select the top of the part. And because I've got 0 here and 0 here, what I did is I selected the top of the part, I've got 0, but what I'm going to do is I'm going to select next to the 0 and then type in minus 0.005 and hit enter. Or you could have just typed in minus 0.005 in this case. And that'll complete all of the changes that we need to make for this toolpath. I'll select OK. I'm looking at the toolpath. I don't see any major issues. I don't see any issues yet. So I've got just that toolpath selected. I'll select the backplot icon. Inside of backplot, I'll select play. Now it's difficult to see the tool because the lines that represent the rapid moves pretty much covered up. So in this particular case, what I can do is I can toggle off the visibility of the rapid moves. Rewind it. And if I wanted to, just toggle on the visibility of the rapid moves again. I can see it well enough. So I like what I see. From here, I'll exit out of backplot. I'll toggle off the visibility of that toolpath. Isometric view. And once again, before I go into verify, I should save my work. So file save. To run it and verify, I'll select the first operation toolpath group. Everything becomes selected. And then I'll select verify. Instead of verify, stop condition collision is turned on. And then I'll select play. And in this case, I'm going to zoom in. The new toolpath is the engraving cycle or the contour toolpath where we engrave. So I'm zooming in. Everything appears to be good. So this is the finished part. And something that we can do once we machine the part complete, we can save the machined model inside of Verify as an STL file or basically save it as an STL file. So let's do that. So I ran all of the toolpaths inside of Verify. We're looking at the completed part. To save it as an STL file, go to verify. So inside of verify, select the verify tab. On the far right, you'll see save stock as STL. I'll select the icon. I'm going to make sure that I save it to the correct folder. So in my class folder, I've got the working folder for each project. I've got drill project 4. I'll open it up. For the file name, you could say drill project 4, or you could add to it drill project 4 complete. And then I'll select save. Now, this will take a moment. You can see that it's processing it. There's an icon that's popped up next to my cursor. You can also see the progress down here, or just some type of indicator that it's saving the STL file. Now, if you had a 3D printer, what you could do is you could, I don't know, maybe not this model, but there are other models that you might want to print. You could, save the STL file, upload it to a 3D printer, and then print out the part. That would be an option you have with the STL file. Mastercam will use the STL files for other things, but that's one of the probably the main function of an STL file. So from here, it's done saving. I'll exit verify. I'll look at it from an isometric view. I'll save my work. Yeah, you'll notice that the toolpath manager is starting to get a little cluttered. I can minimize the stock models, minimize the toolpaths, make more room for additional toolpaths and stock models. One last thing we'll need to do inside of the toolpath manager, we'll need to create the stock model that represents the completed part. To do that, once again, make sure the insertion arrow is at the very end. Go to the toolpath tab. In the stock section, select stock model. For the name, I'll call this, you can call it engraving cycle or finished part. The initial stock shape, once again, I'll use the stock model from the previous operation. And then from here, go to source operations. Select the engraving cycle that we just created. And then select OK. Now, once again, it's difficult to see because it's sitting on top of the solid model that represents the part. So if I go to the level manager and make my name level invisible and make the solid model level invisible, you can see the stock model with the initials machined into them or machined into it. Once I verify that it's correct, I'll make the solid model level visible again. I'll go back to the toolpath manager and I'll toggle off the visibility of the new stock model. I can look at it from an isometric view. And I'll save my work. Now, for the most part, this project is complete. We do need to create a few support files. So before I do that, let's look into, I'm going to open up File Manager and look inside of my working folder. So if I go to Drill Project 4, so far I've created the STL file. This is a 3D object file type. Then I've got the Mastercam file. The Mastercam file is the bulk of what your grade is or what you're going to be graded on. But there are a few support files that we do require you to do. There's going to be the setup sheet, and you guys are not required to do the NC files and the NCI files yet, but I'm going to show you how to do it. And then I'm going to show you how to upload it to Canvas. So first off, we need the setup sheet. To create the setup sheet, I recommend looking at your part from an isometric view. This view will appear in the setup sheet. Select all of the toolpaths. You can even select the stock models. They will not appear in the setup sheet. So select all of the toolpaths. And then In an open area of the toolpath manager, right click. From the file menu, select setup sheet. And we have to fill out some information. So project, we'll call this drill project 4. Customer is San Diego City College. The programmer is you, so put your name. Accept all the default settings. We don't need to customize this at this level. And then select OK. It takes a moment to do it, to create it. There we go. All right, so active reports viewer. It shows us a setup sheet. It shows us an isometric view of the part. It shows us the isometric view of the material. Let's see here. It talks about the operations, the tool holder, the tool. So this could be very useful information that you can send out to the shop floor. Once you create the setup sheet, you want to save it in a format that's useful to you. So in this particular case, we're going to save it as a PDF. So go to File, Save As, and we save it as a PDF, so portable document format. From the Save dialog box, make sure you're saving it to the correct location. That'll make things easier for you down the road. So I'm saving it to the class folder, the project folder. And we'll call this drill project 4. Something I need to complete on there. I'll select save. And then I'll go back to my file manager. Or file explorer. And I'm just making sure that it's saved in the correct location. So there is the PDF for drill project 4. That's my setup sheet. So from here, I can close out of the active reports viewer. We need to create the NC file and the NCI file. To do that, once again, make sure everything is selected. Select the G1 icon. I want to create the NC file, so that's selected. I also want to create the NCI file, so I'll select that. I'll accept the default settings, and then I'll select OK. These are being saved to the working folder. That's what I want. So I'll leave them with the default name for now. So select save. And then I'll do the same thing for the NC file. Select save. And when you save the NC file, it's going to open up a thing called Code Expert. That's our NC editor. And once it's done opening up, we'll be able to take a look at the NC program that gets sent out to the machine. So here's our NC program. This is basically, I like to look at it as the graphical representation of our toolpaths, which we see inside of Mastercam. They're converted to a language that the machine understands. So that's what's going on here. And this is all the code that the machine needs to know to machine our part. So once I see that it looks good, I'll exit out of the Code Expert. I go back to the File Explorer. You can now see inside of my class folder, I have 2 additional files. So you guys are going to be required to turn in 3 files to me: the STL file, the Mastercam file, and then the PDF of the setup sheet. So when they're all inside of one folder, what I want you to do, we need to zip up the folder or compress the folder. So select the working folder. In my case, I'm going to right click on it. From the file menu, I'll go to 7-zip. And then I'm going to I'll select add to drill project 4.zip. And when I do that, it creates this compressed folder or compressed file that I can upload to Canvas. So now I'm inside of Canvas, and I'll look at it from a student view. So I'll go to student view. So this is what you guys are seeing. You're going to go to modules. And now you should be able to access the drill project assignment. I'll select drill project assignment. It's not due for another week. Here is the criteria or the rubric that will be grading your assignment with. So this is a good checkoff sheet. Basically, read through this and make sure that you've done all the required work. To turn it in, I'll select new attempt. Now, I've already, let me do this. I'll select reset student view. And now if I go to modules, drill project assignment. Yeah, so it says start assignment. So I'll select start assignment. And here's the instructions. Using the Mastercam software, generate the model and toolpaths needed to machine drill project 4. Use the videos from the previous lectures to complete this assignment. Once you have completed the assignment, you will submit your work by uploading the Mastercam file to this page. So here, I'll select upload. Choose file. And I'll navigate to, well, in this case, here's drill project 4. I'll select it. I'll select open. You can see that it's been uploaded. And from here, I'll select, now if you need to give me some type of information, if you'd like to provide a note of some sort, that's fine. I'll select submit assignment. Takes a moment. You see the confetti, success. And now if I go to my grades, you can see that we're waiting for Corey or myself. You've submitted it, but it hasn't been graded yet. Once we grade it, you'll see a value here, some type of number value. And depending on how well you did, if you got a perfect score, you'll get 20 out of 20. And if something's missing, we'll downgrade it a little bit, but we'll also give you some type of instruction on what was wrong. And you can always go back in, fix it, and resubmit it. You're allowed to submit it twice. All right, so from here, I've got the file submitted. Go back to the home page. And if I go back to drill projects, I've submitted this. You can see it there. It's not due until next Thursday, September 23rd. And on at the beginning of next Thursday's class, you're going to have a quiz. There'll be approximately 20 questions and pretty straightforward. There's really no way to study for it outside of just doing the work. Work your way through all the videos, do the work inside of Mastercam, and you will be more than adequately prepared to take this exam or take this test. It's just if you've done all the work, you will find these tests to be very, very easy. Nothing you haven't seen. I haven't created these tests to trip anybody up. It's just a way for me to gauge the amount of effort you put into this class. So from here, I'll go back to the Mastercam file. I've already saved it. It's always a good idea to save it. As soon as you're done, save it. And you want to make sure that you saved it at least one last time before you actually zip it up and upload it to Canvas. So out of habit, I'll just save it again. And that's going to complete drill project 4. And that's going to complete, with the exception of you guys submitting the work and taking the test. That's the end of the lectures for module 1.